let's have a look at these lights down inside the cabinet. Wow. Now that looks sweet. Hey guys, welcome to my channel. There it is. It's done. Well, just about, but we can test it. Been working on it late last night and it's just about finished. Just putting some final touches onto it. I'll flip the camera around to show you more. Here we go. I'll start from the isolator here, as I explained before, which is going into the charge controller. From there we got it into the 63 amp circuit breaker, into the bus bars. From there it splits into all different sections, including the battery isolator. We've got the DC step-down converter. We've got the fuse box there. Now these are all on 12 volt. Got the battery meter there. That's the Victron battery meter. We've got our 5 voltmeters as well. And it's all pretty much ready for testing. So down the bottom here, I'll skip that for now. Down the bottom, I haven't put any batteries in there yet. It's all wired up, so it's ready for the battery bricks to be put in there. The UPS, now I've got it down there for counterbalance. It is pretty much top heavy, so it doesn't tilt, doesn't fall backwards on its own unless you really lift it, and then it tends to just fall back. So I'll put that down there for now, but once the battery is in there and that UPS will be sitting up on the top there, that should be quite enough and it shouldn't tip backwards. So this one is the portable 24 volt battery that I had set up for the camping. It is just about charged up. It was in storage for, I don't know, 8 months, 9 months. So pretty much got the ends and plugs going from there into there. But what we can do is test it all out, make sure it's working first with that before we put any of our bricks in there. So one thing I haven't done yet is hook that up. I've got the little latch there. It's got the hinges down the bottom, so I'll show you that. Basically just lifts up, open up. I do need to put some kind of a chain on there so it doesn't flop down. I mean, it doesn't go too far down anyway, but that should be plenty. So I'll put a bit of a chain maybe on both ends just to hold the door from flopping all the way down. So got the 2 fuse boxes in there. It does look a bit messy, but one thing I did learn, and will probably won't do again, is that, where is it? Okay, so that's the negative coming from down the bottom from the shunt. Underneath over here, oh, I fell backwards. All right, so that's my shunt over there. Okay, and that's pretty much going from around the back inside the conduit into there. Now what I should have done is put that hole a little bit further out, because let me do it this way, so that hole a little bit further out, because the distance from that terminal to that hole is very narrow. It's about 1.5 inches, maybe 2, so about 4 centimeters thereabouts, which isn't ideal because it does have a bit of a, so I don't know, it's not that much, but it's okay. I did have it lower, as you can see from the hole, the drill hole there, and that would have been too much of a bend for the terminals. So I did have to push it up higher to give a bit more leeway onto those terminals and less pressure. So that's why it's a bit of an angle, but yeah, doesn't really matter. It's not gonna make a difference to performance wise, of course. It's still gonna work just as well, and just the way it looks a little bit sideways, never mind. All right, so these fuse box over here, that's coming from underneath down the bottom from each battery bank or each battery brick, except for number 2. As you can see, the second one there, I don't have a fuse there because that one is currently not there. So there we go. So we got battery bank 1, future, number 2, number 3, 4, 5 and 6. So that's why the second one is not hooked up at the moment, and it will be there just if I decide, if I do get more cells, to put another one in there. Room for growth. So back to here, I did put the 1 amp fuses in each one, so there's 5 of those. That already is wired up, so that's ready to go. And all these voltmeters pretty much coming down. I drilled a 4mm hole there, and it fits snugly through there. The cable just fits nicely, which is behind the actual meter itself. So we got these 3, which is the bottom row, 3, 4 and 5. And here then we got battery bank 1, 2, which is missing, and 3. And of course all the negatives from those is going into the main negative there. So all those working on 24 volt, and they are also bypassing, where are we? They're bypassing these isolators, circuit breakers. So that way the voltmeters will be always on, as I mentioned in the previous video, except for when I do eventually get those little switches that I put where the bolt is, and that switch will hold that bracket in place as well. So when I do want to check the meter or the voltage of each bank, I can just press the button and they'll display the voltage of that meter. For now, because it's wired directly through those fuses, it'll come on as soon as we plug them in. We won't get any power going into the main system, where are we? Into the battery isolator, because we've got these isolators here. As soon as we click them, close the circuit, then we'll get power going in. So one by one for testing, we'll do all that and make sure it works. So for now, I haven't got that hooked up, which doesn't really matter for now. I just want to make sure that it all works. This battery bank will power that, and everything is wired up properly. I have tested it. I have tested it with my meter. Where is it? Down there. The continuity on all of them is ideal, is spot on. It's not cross-wired in any way, so I've tested that terminal with that one, with this, with that. Where am I looking? With this, with that one. That was always on off, so that's fine. But everything around here is wired up properly, which is what you want. Alrighty-o. Let's power on the portable battery bank. That should give us power to kick the charge controller over. Alright, so main switch on. We've got power there, 28.5 volts or thereabouts. Here we go. That is on, so we are getting power into the charge controller. Woohoo! Here we go. Volt, where is it? Here, of course. Solar panels aren't hooked up yet. That's why we're getting that flashing with code 20. So we are getting power into the charge controller, which is awesome. Of course, the voltmeters, there's nothing lit up there because I don't have those batteries in there just yet. But for testing purposes, we just wanted to make sure that comes on, that's working. So if we were to flick that off, yep, it goes off. Excellent. Now I have put this on there, just haven't screwed it in, just in case. Want to make sure everything is working spot on first before securing all that in. But that, in fact, now is going down here which is, where's my camera? So that positive is going into the first one there, which is currently not connected, obviously. And the negative is going into the bus bar. So that's all good. Now this panel here, we've got the negative, which is going to go into the bus bar. I'll just flick it over here for now. We've got the positive, which is going to go into the first one. So every single one of these came with wire already that had a little fuse on them. I think they're 20 amp or something. I haven't even opened it up, but since I already got the fuse box in there, with their own fuses, there's not much point having two fuses in there. Those ones there, they are just for the fans, so they're hooked up into the fans down in the bottom in the cabinet. So that's what these ones were controlling, as well as the LED lights as well. So that's why I don't need these ones. I'm sure I'll find use for them somewhere else. One thing I want to have a look as well is this. Oh yeah, it's on. It is on. Capacity, select capacity, I think, yeah. Battery capacity, so we need to adjust it. Of course, it hasn't been done yet, so I'll need to hook that up onto my phone as well via the Bluetooth. I've got the app already downloaded from the Victron solar charge controller that I use there. So I'll have the look, might be some updates probably. I'll do all that and then I'll come back to you. Okay, I've hooked up all of these 12 volt fans and all that now, except for the LED light bar. Still yet to make that connection. There it is there. Put the JST connector onto that, and then I'll be able to hook it up onto that one there. Hopefully we can see it, which will be for the light bars. So we can test out the fans, of course. Let's give it a go. So to turn it on, you just need to flick that. Voila, it comes on straight away, sitting at 12.2 volts. Nice. So the 24 to 12 volt step down converter seems to be working fine. Now, one there will be controlling two sets of fans, which is the bottom one there and the top one there, giving us air circulation coming in through the cabinet and then going out there. The second one there will be controlling that fan and that one there, giving us air circulation going in through there, around the cabinet and out from there. And then we got the third switch there, which is for the 12 centimeter fan down in the center there, up the top, which will, I'll just go down, that one there, and that will be sucking all the hot air out. And then number 4 is gonna be for the fans that I talked about for the charge controller, which I haven't done yet. We might not need it at all, so that might not be used just yet. I'm sure I'll find a use for it later on. And the lucky last, number 5, will be for the LED lights that are down the bottom. Alright, let's give it a go. So test, where are we? Number 1. Oh, I can hear it. I can definitely feel the breeze. There's that one. And that one. Alright, so that's that one. Number 2. There's that one. And this one. Good. So there's 4 fans running at the moment. 12.1 volts. And then the third one, which is that one there. Nice. Alright. All the fans are on. And I can definitely feel the breeze coming out of them all. Cool. That one's done. Alright. 12.1. Those two are not used. I'll be able to charge on my phone now too. with the 2.1 amp on both of those USB ports. We've got the 12 volt there as well, and of course the battery monitor as well. Alright, so I'm yet still to feed the positive cable coming from there down through that nominal, whatever it's called, and then through the cabinet and down here, and also then the negative as well, which will go into that UPS, giving me 240. Alright, I'm happy with that. Let's get that thing programmed and we can actually start testing with our battery banks as well. So now, before we put them into the cabinet, what we do need to make sure is that they are all roughly the same voltage. Okay, so we got our trusty ISDT battery go, which is quite cool. What we want to do is test them, each brick individually. Okay. 28.63 volts. So yeah, I'm pretty happy with that. I reckon we can start hooking them all up. What do you think? Any comments? Let me know down below. Okay, one thing I haven't covered. Originally when I built these packs, I did mark them as pack 1, P1, 2, 3, 4 and 5. So that's pretty much the daily BMS that each pack is using. Now obviously, as we are not gonna be connecting battery bank number 2, we just need to rename these. So it will be P1, P3, that will be 4, 5 and 6. So I'll do that quickly now with the texter, mark them all right, and then we can start hooking them up. Okay, here we go. They're all marked now. Let's ready to start plugging them in. Alright, all 6 of them, or should I say all 5 of them now hooked up and ready to go. Let's line them up. Now, you might say, what happens if they fall over and knock into one another? Well, alright, I did think of that. That's why I got these fire retardant foam like jinging thingy. And I've got 5 of these, which I can pretty much stick in between, like so. I do need to cut it down a bit by the looks of it. Yeah, that's it in the back already, so I'll cut it down by one of these notches and that should fit in there nicely and prevent them from knocking into one another and causing some havoc. Here we go. Now that they are all hooked up, the voltmeters come on straight away. They are bypassing that circuit breaker, so we can always see what the voltage is of each pack without actually having it connected, switched on. So if we were to now turn on all these breakers, we can see the battery monitor came on straight away. Let's do every single one of them. Voila. Okay, bottom 3 are on, top 2 are on. Let's have a look. They all pretty much the same voltage, so now they're balancing each other, and that's the beauty of running them in parallel. Okay, that's pretty good. Now let's give the charge controller power. So if we were to flick this over to the left, they'll give us number 1, which means that only the top 2 batteries are being used. The bottom one is number 2. That one there on the right. Okay, or we can have them both running. So let's flick over to both. There we go. And now, flick the circuit breaker, which would give us power to the charge controller. There we are. 28.6. 28.6. Yeah, I think some of these voltmeters might be a little bit off. They aren't the greatest. I can't really 100% rely on them, but 0.1 of a volt is not all that much different, so I'm happy with that. Let's have a look now. If we were to flick over this one here, which will enable the DC to DC step-down converter, 24 to 12 volt through that circuit breaker, and this panel comes on. So now I'll show you quickly on the inside of this cabinet. Okay, I have that little cable, the wire there holding it down, so these cables here, they don't get any tension on them and they don't get pulled out if it does open too far out. But it's all pretty much wired up. Each of these fuse boxes contain 1 amp fuses, except for the very first one, which is running this panel, and that one there is a 20 amp, same as that one there, which is a 20 amp, as well as that circuit breaker there, 20 amp, although the step down converter is a 30 amp max, so we shouldn't need to use all that much power. I just thought of something else. Let's have a look at these lights down inside the cabinet. Whoa. Now that looks sweet as. What do you guys think? Let me know in the comments down below. Is it a yay or nay? You like it or you don't like it? Is it a good idea? I think it is. I think it'll do the job for me. It might not suit for your application, but for my application, to run those 2 fridges, this will be ample power. Alrighty-o, so it's getting late now, so I better leave it there. If you have any questions, feel free to leave them down in the comments below. If you liked the video, hit the like button, and don't forget to subscribe. Thank you, stay safe out there, and be good.